Today's lesson is on classification and sources of hydrocarbons. Hydrocarbons are organic compounds composed exclusively of carbon and hydrogen. They are the foundation of global energy and the petrochemical industry. Broadly classified into aliphatic, open chain hydrocarbon, and aromatic, cyclic chain hydrocarbon. This classification is based on their structure and the type of bonds they contain. All hydrocarbons have the molecular formula of CSHY, where X and Y are positive whole numbers. Examples are methane, CH4, propane, C3H8, benzene, C6H6, etc. Hydrocarbons are derived primarily from fossil fuels. Sources of hydrocarbons. The natural sources of hydrocarbons are as follows. A. Plants and animals. Organic compounds are obtained by isolation of cellulose, carbohydrate, fats, vitamins, oil, etc. B. Coal. Organic compounds are obtained from coke and coal tar through pyrolysis or destructive distillation. Coal is a solid fuel. C. Natural gas. Natural gas is a gaseous fossil fuel that collects in underground rock formation, often alongside or above petroleum reservoirs. It is primarily composed of the simplest hydrocarbon, methane, often over 90%, but also contains smaller amounts of ethane, propane, and butane. Natural gas is extracted and used extensively for electricity generation, heating, and cooking. D. Petroleum. Petroleum is a dark viscous liquid found in underground reservoirs and is the largest source of hydrocarbon. It contains a complex mixture of thousands of different organic compounds. Through a process called fractional distillation at refineries, crude oil is separated into various fractions based on their boiling points. E. Fermentation. Hydrocarbons can be obtained from fermentation, though it requires specific techniques like the use of metabolic engineering to alter microorganisms or combine fermentation with chemical engineering. Classification of organic compounds. On this slide, we have the classification of organic compounds. We said the organic compounds are divided into two main groups, the open chain or aliphatic organic compounds and the closed chain or cyclic organic compounds. The open chain or aliphatic organic compounds are further divided again into two groups, saturated and unsaturated. Under the saturated, we have alkanes. An example we place here is ethane. And then under the unsaturated further divided into two groups, alkenes and alkynes. We have an example of an alkene, ethene, and an example of an alkyne, ethyne. On the closed chain or cyclic hydrocarbons, they are also divided into two groups, the homocyclic compounds and the heterocyclic compounds. On the homocyclic compounds are further divided into two groups, the alicyclic compounds and the aromatics. The alicyclic compounds will have example cyclopropane, cyclohexane, and cyclooctane. And then the aromatics are further divided into the benzenoids and the non-benzenoids. The benzenoids will have example of benzene there, and then azulene and tropolone. And then we'll have this heterocyclic compounds. We have given an example of tetrahydrofuran. Each of these groups will be discussed. Open chain or aliphatic hydrocarbons. Hydrocarbons are classified according to their arrangement of carbon atoms in the molecule. Open chain hydrocarbons, also known as acyclic or aliphatic, are organic molecules composed solely of carbon and hydrogen compounds, arranged in linear or branch chains rather than closed rings. They are divided into two groups based on the presence of multiple bonds: A. Saturated aliphatic hydrocarbons and B. Unsaturated aliphatic hydrocarbons. A. Saturated hydrocarbons, meaning they contain only single bonds between the carbon atoms. They are called alkanes. They are the simplest type of hydrocarbons, and their general formula is CnH2n plus 2. Examples are methane, CH4, butane, C4H10, etc. Unsaturated aliphatic hydrocarbons. They are those that contain carbon-carbon double or triple bonds in the molecule. Examples are alkenes and alkynes. The alkenes, they have the carbon-carbon double bond. They have the general formula CnH2n. Examples are ethene, propene, etc. The alkynes, on the other hand, contain at least one carbon-carbon triple bond, and their general formula is CnH2n minus 2. Examples are ethyne and propyne. Because this class of hydrocarbons are reactive and combustible, they serve as the foundational building blocks for fossil fuels like gasoline and natural gas, etc. Closed ring hydrocarbons. These are compounds that have carbon atoms linked together to form one or more closed rings. They are divided into two subcategories, homocyclic and heterocyclic. On this side, we will focus on the homocyclic organic compounds. Homocyclic rings formed entirely of carbon atoms. They are further divided into aromatic compounds and alicyclic compounds. Alicyclic compounds resemble aliphatic compounds but in a ring structure without aromaticity. Example, cyclohexane. While the aromatics are divided into two groups also, the benzenoids and the non-benzenoids. Aromatic group contain a highly stable conjugated ring system that creates a delocalized pi electron system, benzene, naphthalene, etc. The most common example of an aromatic compound is benzene, which has 6 carbon rings with alternating single and double bonds. The non-benzenoid organic compounds are cyclic molecules that are aromatic but do not contain a traditional benzene ring. Remember, they do not contain a traditional benzene ring in their molecular structure. They are aromatic but lacking a benzene ring, e.g. azulene and tropylene. The alicyclic compounds. Alicyclic hydrocarbons are non-aromatic ring-shaped molecules that behave like open chain. They behave like aliphatic compounds, e.g. cyclohexane. An alicyclic compound is an organic compound that is both aliphatic and cyclic. It contains one or more carbon rings, saturated or unsaturated, but does not exhibit aromatic properties. They lack the special stability and continuous delocalized pi electron system found in aromatic compounds like benzene. They In their reactivity, they generally react like the open chain counterpart aliphatic, undergoing addition or substitution reactions. We have the saturated alicyclic cycloalkanes, and we have the unsaturated alicyclic cycloalkenes or cycloalkynes. Examples of cycloalkanes could be cyclohexane, and an example of cycloalkyne is cyclooctane. Another group of compounds we're considering are the heterocyclic compounds. The heterocyclic compounds are cyclic organic molecules that contain at least one heteroatom, typically nitrogen, oxygen, or sulfur, within their ring structure rather than solely carbon. Don't fail to subscribe to this channel, like, and comment. They are foundational to life, comprising over half of all known organic compounds, including DNA, vitamins, and the majority of modern pharmaceutical industry. Organic chemistry is an interesting aspect of chemistry. Continue to be with me on this channel. Don't fail to subscribe. Subscription is free. Like and comment on this video. So for the heterocyclic compounds, we are having here a compound called tetrahydrofuran, thiopene, and pyridine. In addition to these main types, hydrocarbons can also be classified on whether their carbon atoms are arranged in chains, linear or branched or ring. Linear hydrocarbons have their hydrocarbons arranged in a straight chain, like alkane. Branched hydrocarbons have a tree-like structure. Their structure is like a tree. And then cyclic hydrocarbons, as the name suggests, have their carbon atom arranged in a ring or cyclic form. Understanding the classification of hydrocarbon is crucial in chemistry, as it helps predict the properties and reactivity of different compounds, and it forms the basis for nomenclature, the system of naming chemical compounds. Study questions. Define the term hydrocarbon. List 3 natural sources of organic compounds. What are benzenoids and non-benzyl compounds? What is the difference between linear and branched hydrocarbons? What are heteroatoms in organic chemistry? Don't forget to like, subscribe, share this channel with your loved ones. See you in the next class.